Understand Beer's law and its graphical representation. According to Beer's law, absorbance, A, is directly proportional to the concentration, C, of the absorbing species. A equals ABC, where A is the molar absorptivity and B is the path length. On a calibration plot of absorbance versus concentration, this direct relationship should yield a straight, linear best fit line passing through the origin. Observe the deviation of the data point on the graph. By examining the provided calibration curve, the data point corresponding to the 0.600 molar solution lies significantly above the best fit line. This indicates that the spectrophotometer recorded an abnormally high absorbance reading for this sample compared to its actual concentration. Understand how a spectrophotometer calculates absorbance. A spectrophotometer measures absorbance by comparing the intensity of light entering the sample, I0, to the intensity of light that emerges, I, and hits the detector. The instrument calculates absorbance based on how much light is blocked. A equals log I over I0. Consequently, any physical factor that scatters, blocks, or absorbs light, other than the dissolved Q27 molecules themselves, will reduce the amount of light reaching the detector, causing the machine to calculate an artificially inflated absorbance value. Identify the cause of the elevated absorbance. If the outside of the cuvette was not wiped clean, contaminants on the outer walls, such as fingerprints, grease smudges, dust, or water droplets, will scatter or absorb a portion of the incoming light beam. Because less light reaches the detector, the spectrophotometer records an artificially high absorbance value, causing the plotted data point to deviate upward above the expected linear calibration line. This confirms option D as the correct explanation. The correct answer is option D. The cuvette used for the 0.600 molar solution had not been wiped clean before being put in the spectrophotometer.